Okay, so second lab script, test your understanding of Zipf's law. So, Mike, tell me what on earth is Zipf's law?
Zipf's law is where we look at the most frequent, the graph, the plot, the trend of the most frequent words against a ranking. So we're going to have a look on the Moodle page. There's a zip.py file that is the last part of the lab script 2, and we're going to do our usual off the cuff, going through this question.
Fine.
To see if we can.
So our objective here is to take a big corpus. So we're going to take Moby Dick corpus, and we're going to look at the frequency of the occurrence of certain words, and we should see this trend that just a few sets of words are used very frequently, and the majority of words are used very, very occasionally. Yeah?
Yep, exactly that. Okay, so straight away we've opened the zip.py file.
That's the one given to us, yeah.
So straight away we remember that we have our raw input here. We need to change that to inputs because of the
because we're using 3.5 rather than 2.7. That's right.
And I'm also going to take away this pylab.close so that we don't hang idle with the idle hanging bug. And what that will do is that will leave the graph window open and it won't close it for us.
Doesn't make any difference if you leave it in there. You're just going to see a little spinning disc rather than
So I'm going to get rid of both of these lines
for
this. Okay, and we're going to tackle this bit by bit. Now what will happen now is we will see these make plots and these make plots, and what will happen now is one of them might try to overwrite the other window.
Yeah.
So we're going to see how that comes out. Okay, so
this is Matplotlib we're using here, isn't it?
We know we have all our imports up here.
Yeah.
We're using all the NLTK word tokenized frequency distribution and most likely estimate probability distribution.
Yep.
And we're also pylab, which is Matplotlib. So we're going to use this for our plotting. And we have our make plot function slightly changed from before. I'm also going to remove this pause here. So all we're going to do now is draw our graph and show it.
Which is going to be text 1, which in this case is Moby Dick as requested. Yeah.
So MD tokens, we're getting the tokens from text 1.
Yep.
And MDF disk, we're doing our frequency distribution on the tokens.
On the tokens,
yeah?
Yep.
So now we can see 2 do 1. The above frequency distribution is over tokens in Moby Dick without removing punctuation and
okay, so we've got to remove the punctuation first.
Lowercase. Modify the code to remove punctuations and convert to lowercase before computing the frequency distribution. Now we know how to do this. We've already done it in the previous questions for the lab script.
That's right. So we need to use RE, don't we?
We do. We need to use a regular expression. We need to do a loop. Yep. And we need to go through each one
and remove everything that we see in there according to the regular expression.
Exactly. So just to keep this video down.
So cut and paste from your previous code. Don't we'll write it in, but you students that is, cut and paste from your previous code, and that will save you an enormous amount of effort. Oh, Mike's going to do the same.
I'm going to do the same on this one. So MD tokens no punct. We're going to create an MD tokens no punct up here. Yes. Which converts to lowercase. It goes through just as we've done in the previous things. Yeah. Then we're going to move this frequency distribution to happen after.
Let's go to this RE expression first. So on the RE expression, what are we taking out, if you see what I mean?
Right, well, the RE is searching for words.
Yeah.
So it's actually identifying the space before and after, or what the regular expression syntax of \w would classify as a word.
Yeah.
And it's returning each word in a loop of the tokens.
Yeah.
And then it's making it lowercase.
Yep. So there's no punctuation. That's going to get rid of it.
Yep.
So the \w already understands what punctuation is.
Exactly.
I see. Yep.
And then we're putting that into a new variable called MD tokens no punct.
Yep. Gotcha.
And now we're computing the frequency distribution using our new variable.
Yep. So MD tokens no punct is a list of words. Is it a list or is it a string?
This will now be a list.
List, yes. Otherwise we couldn't step through it.
Yep, that's right. Yep. And so now we can go back to our given code, and we can see that after we've completed the frequency distribution that's now completed on lower cases without punctuation, I am going to sort the list in reverse order, so we get the most frequent
frequently occurring first,
and we're going to create a rank, which is the ranking of that frequency, so we get our x-axis.
So first, second, third, fourth, and so on.
And then we're going to plot this. And for now, I'm just going to remove this down from here using a comment so that we just see this first plot here. Okay, so we'll save that and we'll run it.
Think it'll work?
I hope so. I hope so. We download our corpuses.
Something's happened.
Something's happened, but it's stopped.
We don't have a graph.
We don't have a graph now.
No, the program's terminated. Look, because you've got the 3 right-hand side arrows.
Now, why has the program terminated? This is interesting. So where did we get to? We got to we've downloaded there. We've done our make plot down here. And let's work out why that program's terminated down there. If we can print some bits here. Let's have a look here. Let's do some printing.
Well, it's like it didn't open the graph plotter. I think everything's in place. So
there might be it might be hidden somewhere down here, which may be because we need to run that big close in there. That may well be the case. Okay, so let's just put that back in there for now. Let's do the draw and let's do the pause. Let's do our pause here, and then let's try that. We'll put that pause back in. And we'll see.
You were playing about down there, weren't you?
Let's just print option here. Let's put that pause back in. And we'll see where we get to. This is Python working through off the cuff. There we go.
It's more like
okay, so we need to include that pause up there. So now we have.
So that's obviously part of the library there, because I think what's happening is there's 2 threads going on there, isn't there? There's the draw, and that's obviously the draw is blocking, so we have to put a delay in there. That's all.
Yeah.
Didn't realise that was quite so critical myself.
Okay, so we have our frequency distribution. Everything good. Yeah. If we zoom in on this part here, we will actually see what's going on. Here we go. Now we can start seeing a little bit better.
So just a few words. So looking at that, what that's telling me is there's 30 words.
Yeah.
Form the majority of the language in Moby Dick.
Which is Zipf's law.
Zipf's law, and that's true across any text.
Any language.
Any language.
Yeah. Any language.
How fascinating.
Yeah. Okay.
So that means I can learn a foreign language if I learn 30 words.
Yeah, you can certainly get by it. Okay, so looking back at that text, there, so we've done 2 do 1, no problem. The above frequency distribution is now happening with lower cases and words, yeah? And now we have another plot down here, and this is converting it into a log scale. So I'm going to just turn this plot off. And
so I guess the reason we want to do that is because this graph is all squashed up on the left-hand side, and we had to zoom in, right?
We had to zoom in.
So if we put it on a log scale, we're going to see it stretched out a bit more, and we'll see Zipf's trend a lot more clearly identified. Yeah.
So just to show this, I've commented out this plot here, and I'm going to run this plot down here. And it's exactly the same, but it's going to show it in a logarithmic scale. And there we go. There we go.
Interesting.
So the only difference with this is when we call make plot here, we've used this log text down here, and when we're in the function, it searches for this log text and tells matplotlib to make the axis logarithmic.
Yeah.
Okay, so
you're on log there, aren't you?
Yeah, we're on log.
Okay. I'm just wondering what would happen if we did log linear. It would be more revealing.
We could certainly try. I mean, on the what would you like to see on the x scale or the y scale?
Well, I think I want to see on the x scale. I'd like that to be linear.
Linear. So let's just comment out that there, and we'll run this again, and we'll see what happens. So all this will do is it's only changing the y scale to be logarithmic now.
You see, that's more a graph that I can understand because it's got a shape I'm familiar with. So that tells me that, tells me the same information as before, just a few words are used very, very frequently. Okay, students, so feel free to play about with log scales, linear scales, and you can see why we use log and linear, because it just squashes things up neatly, so the graph tells you more information or tells you the important trends inside.
Okay, now we're going to tackle this last to-do, which again reflects on things that we've already done in our previous lab questions. So we're going to plot figure 2, and we're going to plot the rank version frequency again, but we're only going to do the most frequent 100 words.
100 words, okay.
Okay,
yep.
so to tackle this, what do we need to do? We know that we have that most common function that we've done in the previous lab script, so we can definitely use that.
Well, even I know how to do this.
Yeah.
We just do the 0:100 trick in Python, don't we?
Well, that is slicing, yeah, that's
Yeah.
another option, but we have that most common function as given from NLTK,
Yeah.
where we just pass an argument to it. But the difference is now that will return to us a dictionary object.
Yeah.
And so we need to break down that dictionary object, and I'll show you why. Okay, I will show you why. We also need to create a rank that is only 100
Yeah.
points,
Yeah.
so that our x and y.
But we could go further up in our code and just restrict it to the first 100, but
Yeah,
we don't want to because we want to plot the other graphs
Yeah.
as well. Gotcha.
So I'm going to first of all run tackle those two things that I've just talked about. We're going to create a new ranking that starts at 1 and finishes at 101.
Okay.
And the reason for that, in fact, it starts at 1 and it's 100 in length. Yeah.
Yeah.
So what that will do is that will include 100 in our processing.
Yeah.
Okay. So we now have a new.
That's not the first 100 words in Moby Dick. That's the first 100 most frequently occurring words in Moby Dick. Yeah.
Okay, then I'm going to do, we're going to look at our frequency distribution that we've computed up here and take our most common 100 using the most common function.
Yeah.
And we're going to store that in this new variable called mdfdis most common. Now that is going to be a dictionary object. And let me give you an example of that by just printing it.
Yep.
Right, this is not going to be the object that we've already
So
seen.
the dictionary is going to have an index followed by a value.
Yes.
Yeah.
So in this case, it's like having a two-dimensional array.
Yep.
Right,
That's
which
exactly
means,
what we see there.
as you can see, here are the list separators, yeah, and these are the items of the list. So this is element number 1, this is element number 2, and as you can see, each element has 2 parts.
Yeah.
This is the dictionary part of it, and we don't want the word, we just want the value.
Yeah.
So we're going to loop through this output, and we're going to build a new list that just contains these values.
Yeah.
Yeah. So I'll take away this print here.
Yeah.
And then we're going to put a little piece of code in here, and this little piece of code is going to
tell me pull out the second value.
Yeah, it's going to create a new list called new frequency list.
Yeah.
It's going to iterate 100 times because we've only got 100 values here.
Yeah.
And then inside is going every time in the loop iteration, it's going to add or append a new value to the list, which is the part of our dictionary list that we've been returned, the second element. The first element will be 0.
Yeah.
Sorry, the second part of the first element. So this I here will represent the element that we're looking at.
The and it.
No, it will the line in the list.
Ah.
So if we look back at our so this will be the first element. This will be the second element. So that it's working in pairs. So the I part is representing that I want to look at this pair, this pair, this pair, and it's going to iterate through.
Gotcha.
And then the second part here,
one there
0,
indicates
1, 0,
Yeah.
1, 0, 1. And I'm saying I just want 1. I just want 1. I just want 1.
So
it's
the
the
number.
index of the element.
Yeah, gotcha,
Yeah?
gotcha.
Okay, and I'm going to install that, store that into this new list here. And then, of course, I'm going to plot that graph using my new variables.
Yeah.
Yeah?
Fine.
So let's see what we've got here. We'll run this, see what we end up with. And there we have it. Our most 100 text.
That's really meaningful, that graph.
That's
isn't it?
really me. Well, let's turn it into log and see what happens. To do that, I can just quickly change this down here. We're going to get log on both axes again.
You better shut that plot first, I think.
Log on both axes.
Well, it sort of tells me a bit, but that's a bit alien to me. I think I preferred it like it was before.
let's have a look on, log on just the x-axis and see how that comes out. Again, with Python, with any programming language, there's more than one way to achieve where we've got to today.
Yeah, I think the linear graph was much more meaningful for both of those, don't you?
So,
but it's important to say that by doing the log of the graph, we're not changing the data at all. We're just showing the way in which it's plotted.
So there's more than one way to tackle these problems in Python. We've chosen this way to iterate through and store new lists because it made it easier to understand.
We've still got the log turned on.
Still got the log turned on, and we
log, that's down the bottom.
Oh, sorry, I've changed the wrong one. So we just chose it to go this way.
No, we wanted it linear, didn't we?
Yeah, we did, but I changed the wrong one this way.
Yep, you did the commented out one.
Because we chose to iterate through the list to show you it in its simplest terms. There's lots of functions I'm sure that you can find that will process the dictionary lists and the data in a much simpler way. But that is the last video, the last question on the lab script. Give it a try yourselves. Don't just watch this video and think that you know it. Actually
go
do it
through the
yourselves,
syntax and get in all the muddles that we got into as well. So nice demonstration of ZipSaw, I think.
Excellent. Thank you very much.